Hi, my name is Roger,
My name is Yecheng.
and this is our CS122A final project.
Here is our main board. Atera D1 SoC comes with an ARM core and FPGA on same chip. We use the Python and Verilog to program it. And this is Arduino Uno. It's running the home security system, which is emulating the pattern lock, which is similar to the Android phones.
And this is the Amiga 1284. It's controlling the lighting system of the house.
For all the components, we have PIR sensor, THT11 temperature and humidity sensor, relays, and a joystick, shifter adjusters, LED matrix, and motor driver and a stepper motor.
We also use this ESP Wi-Fi module, 2 servos to control the camera mount, the camera module itself, an LCD display, some LEDs, 2 more PIR sensors, and a joystick to control the camera module.
This is the website we designed for our project. We used the Node.js, PHP, HTML, CSS, JavaScript to design this whole website. So here is the login user interface. We click login to enter the control panel. Basically, we have 3 panels for our whole system. The first one is the lighting system, the second one is the environment system, and the last one goes to the door security system.
The website is used to control the lights. So as you can see, if we turn the lights on in one of the rooms, you can see the lights go on. And if we turn the lights off, you can see the light go off as well. And if we scroll through the settings on the LCD, you can see that the rooms are still unoccupied and there's a good lighting, but we're still able to control the lighting of the house. Aside from the lights being able to be controlled by the user, they can also act independently through the help of these PIR sensors and photoresistor. And if we scroll through the LCD display, we can see that currently we have good lighting condition. The room lights are off, so are the living room lights. The room is unoccupied, and you can see that the living room is unoccupied. And since there's good lighting condition, so we'll scroll back to the lighting condition, and you trigger the PIR sensors, you can see that none of the lights are going off. And you can see it again reflect here as well. So the living room is occupied, the room is occupied, but the lights are still off. And now if we simulate poor light, as you can see, the status of the lighting condition signals poor lights. So now if we were to trigger the PIR sensor, so let's inhabitate the room, you can see the lights start to turn on. So if we scroll back here and we go to the room, we can see that the room is currently occupied and the room lights are at mid-level. And the thing about the lights is that they store the user's preferred intensity, and it takes the average of the past 5 so that you never have a strong brightness or a light level that you don't desire. EEPROM was used to store the preferred value of the user as well as the past 5 values to take the average. And right now we see both rooms are currently occupied. So we go down here to our menu and we scroll through, we see the room is occupied, the living room is occupied, the light condition is still poor, and you see the room lights are mid and the living room lights are mid as well, since that's what our preferred value was set at prior to the demo. And after 5 seconds of no motion, you see the lights go automatically. So now if we go back and we adjust the brightness level, so we're changing it now so that the past 5 values could be high. Now that we've changed our past 5 values, we can see now that if we were to trigger the motion sensor and we look down at the LCD display, you can see that now the preferred setting is at high, and we go to living room lights and they're still off since there was no motion that was triggered. This LED matrix was used to emulate a pattern lock similar to that which you would find on your Android device. So if we were to enter the right combination, so here I'm just gonna enter an R, so we go down, and we accept that combination, we can see that the door will unlock and automatically lock on its own. Aside from that, you can also use your interface to unlock the door through the click of a button. So you can see that the door unlocked and now it's locked. And you can also reset your pattern lock to whatever you'd like. So say we just want to enter a single line. And you accept it. And now, if we were to enter that pattern lock and we accept it, you can see that the door unlocks and locks on its own. And if we were to enter something that was incorrect, say something like this, and you accept it, you can see that there's no movement in the door.
For the D1 SoC part, we are using the IPJ on the board to get the environment data from this sensor, which is displayed on the 7 segment displays. The first one is humidity, and the second and third one are the degrees in Celsius and Fahrenheit. So you can see the exact information on the website, which is displaying here. Sorry, the motion is triggered. So for the motion sensor, if you check the motion sensor, there's LED on this board, and also your website notifying you someone is breaking your house. And for the relay part, we are intended to using it to control the air conditioning, which is controlled here. Like turn on it, and this is on.
This joystick is used to control the camera mount, which attached to it is the camera. And if you were to look up at the monitor, we can see that everything, oh, that's me, is being displayed on this monitor. And ideally what we wanted to do was send a picture to your mobile device or some footage of an intruder in your home. But that proved to be a challenging task due to timing constraints.
So for the camera module, it's sending AV signals to the IPJ board, and the IPJ board decodes the signals and encode it again to VJ output so that we can see on the monitor.
Hi, my name is Roger.
You forgot the course name.